evening, students. Today we are going to learn about the process synchronization. Process synchronization. When two or more processes cooperates with each other, their order of execution must be preserved, otherwise there can be conflicts in their execution and inappropriate outputs can be produced. A cooperative process is the one which can affect the execution of other process or can be affected by the execution of other process. Such processes need to be synchronized so that their order of execution can be guaranteed. The procedure involved in preserving the appropriate order of execution of cooperative process is known as process synchronization. And there are various synchronization mechanisms that are used to synchronize the processes. So processes we know that is program and execution. So when two or more processes cooperate with each other, the order of execution matters. Otherwise the output will be inconsistent. We cannot depend on those outputs. So there can be conflicts in their execution. So that should be properly synchronized so that one can work without interrupting the output of the other. So next one. So that is the next is race condition and critical sections. So when several processes access and manipulate the same data concurrently, the final outcome of the execution is not predictable. The final outcome depends on the particular order in which the access takes place. This is called race condition. So the two terms that we commonly use in the process synchronization, one is race condition and critical section. So race condition is that the order of the execution the output will depend upon the order of execution. That is, final outcome of the execution is not predictable. It can be said that in which order the processes have executed, that reflects the output. The next one is the critical section. That is the region of a program that try to access the shared resources and that may cause race conditions are called critical section. To avoid race condition among the processes, we need to assure that only one process at a time can execute within the critical section. So critical section is a set of instruction where the two processes are accessing, or the shared resources are used. So in that critical section, that set of code should be accessed by only one process at a time, and the other process have to wait. So that is called that region of the program, we call it as critical section. You can see that the critical section problem considers system consisting on n processes. That is, n processes of P0. When it starts from P0, it has P and P of n minus 1 processes are there, and each process has a segment of code called a critical section, in which the process may be changing common variable, updating a table, and writing a file or so on. That is a process, that is a region where updating the table, writing a file, all these things happens. When one process is executing in its critical section, no other process should be allowed to execute in that critical section. That is, no two processes are executing in the critical section at the same time. Each process must request permission to enter the critical section. So when two or more processes are, each process should request permission to enter and make sure that no other process is executing in the critical section. And the section of the code implementing this request is called entry section, and the critical section may be followed by an exit section, and the remaining code is called as remainder section. So you can see that here critical section problem in operating system, that is, there is a while loop. That is, when the condition is true, it will enter. So entry section is there, then the critical section, then the exit section, and then comes a remainder section. Requirement of critical section. So what are the requirements of critical section problem? One is mutual exclusion, next one is progress and bounded waiting. So mutual exclusion, that is, if process PI is executing in its critical section, then no other process can be executed. Progress means that if one process doesn't need to execute in the critical section, then it should not stop other process to get in. That is progress. If one is not entering, the other one, let it enter and execute. Bounded waiting, there must exist a bound on which number of times other process can enter the critical section after the process has made a request to enter its critical section and before the request is granted. And this ensures that no process waits forever to enter the critical section and prevents starvation. So these are the requirements of critical section problem: mutual exclusion, progress and bounded waiting. Rest we will see in the next class. Thank you.